Hi again, guys. So let's try this problem. Just coming out of the oven, meaning the printer. There are two questions in one. Let's start with the first one. It says, determine the angle at which this force must act at A. So right there, the force is applied there, so that the moment about that force with respect to the point B is zero. The there are several ways that you can do this. At least there are two of them that I can think of. The first one will be, okay, if the moment at B is zero, what I have to do is summation of moments with respect to the point B has to be zero, and I'm going to assume counterclockwise as positive. And we follow the same procedure that we did before. So we're going to get this force, this component, and this component. We're going to start with this one, for example. This one will be 500 sine, because it's the same as this side, right? Sine of the angle. And this other component will be 500 cosine of the angle. So I'm going to start with this force, 500 sine of the angle, multiply, the force is vertical, the distance has to be horizontal, and it's 2. I'm going to put the distance here first. And then you study the direction. You put your finger, you apply the force, rotates clockwise, meaning this is going to be negative. And now we start with the other force, which is 500 cosine of the angle. The force is horizontal. The distance between the point B and this force, remember transmissibility, right, is this distance, vertical distance, 0.3 times 0.3. And then you apply the force. If you apply the force in this direction, the rotation is going to be counterclockwise, meaning positive according to our convention. And now you just group these things correctly. I mean, you can say 500 times 0.3 is 150 cosine of the angle, and minus 1000 sine of the angle, and that has to be equal 0. And then you can move around and say sine divided by cosine, sine of the angle divided by the cosine of the angle. I mean, I pass this to this side, right? So if I pass this to this side, this is going to be 1000 sine of the angle. So I'm going to divide cosine here, and I'm going to pass this to the other side, 150 divided by 1000, and that will be the tangent of the angle. So the tangent of the angle will be 150 divided by 1000, and the inverse tangent will be 8.53. There you go. So another way to do this also is paying attention to what is happening there, and working with some knowledge that you should have already. That is, in order for this force to not produce any moment with respect to the point B, in reality, the force should be acting, or the line of action of the force should be acting in the same direction of that. So the force in reality is not acting this, it's acting like that, in that line of action. And then I can calculate this angle, which is the same angle as this angle here, and say that theta is going to be the inverse tangent of this distance, 0.3, divided by this distance, which is 2, and that will give you also theta equals 8.53 degrees. Two ways of doing it, really, really easy, but you have to focus in the details. The more you practice, the more you're going to understand these type of problems, and the faster you're going to solve them as well. Thank you for watching, guys. Keep learning and keep watching.